This is our post-lab discussion, and we had this formula as our finishing point. If I rearrange that, if I times both sides by m, I get F equals ma. And that's our starting point for our notes we're going to talk about here. So this is our F equals ma equation. You can write this down as unbalanced force notes as a bit of a heading. And just pause the video as you need to get the notes down. I had F equals ma before, but the true formula has this funny big E, and that is a Greek letter, sigma, and sigma means net or total. So the total force is equal to ma, or the net force is equal to ma. So that's our starting point. So that's actually Newton's second law. So Newton's first law is if something's got a balanced force on it, it will keep doing what it's already doing. So it'll keep moving at a constant speed, or it will keep staying still if it's staying still. Newton's second law is what happens if there's an unbalanced force or a net force? Well, it will cause this acceleration depending on the mass. One of the things that came out of our experiment was we had some funny units for the gradient, and it turns out that gives us a definition for what a Newton is. So a Newton is a kg, we get it from here, mass is a kg and acceleration is in meters per second. A Newton is a kg per meters second per second. So here we are here. So this is what a Newton is, yes, but just if you ever have to do some rearranging, this is what it's made of. It's made of, and it comes from mass times acceleration. Mass is the kg, and the acceleration is meters per second. So that's by definition what a Newton is. The other thing that comes out of this is if you rearrange it back to the way we had it before, we have acceleration first, is that acceleration and net force are proportional, but acceleration and mass are inversely proportional. Which means if I increase the mass, I decrease the acceleration. If one gets bigger, one gets smaller. If I double the mass, I halve the acceleration. If I halve the mass, I double the acceleration. Just pause to get that the notes down on that slide, because I've got one more slide in this video to do, so I'm about to go to that now. Okay, what does it all mean? It all means that you can use this formula to work out an acceleration or to work out a net force and vice versa. But the key point you've got to have is that net force gives you a mass times acceleration, but also net force can be found from a force diagram. You might have this for a force diagram here, for example. And you might have 2 newtons and you might have 8 newtons. So the net force in this is 6. So you've got to realize that net force turns up in 2 places. It turns up 1 in this formula and 2 in our force diagrams. And people miss that. They really miss the connection between our force diagram and then being able to turn it into this. So for example, I've got that one there. Let's say I've got a block of wood which is being pushed. My man's pushing it, and I draw a force diagram for it. Let's say it's a 5 kg block, and we'll make this really easy. We'll pretend that the strength of gravity is 10 newtons per kg, so I made that 50, just rounded it off. This is also 50, and let's pretend this is 100 newtons, and this is 80 newtons. Okay, I can find the net force from this. I can find the net force because these cancel out. I've got 80 backwards and I've got altogether 20 this way. So that's the first, I've kind of done this one here. Net force can be found from a diagram, but also we can use net force with mass times acceleration. So I could work out the acceleration of this one, because I've got the net force now, 20 newtons, and I've also got the mass, 5 kgs. 20 divided by 5 is 4 meters per second. Okay, so what I'm stressing in these notes at the moment is that yes, we've now got a formula for unbalanced forces and how it leads to acceleration. But don't forget that you can get the net force also from your force diagram, and you can connect the force diagram to this equation. And you're going to do that quite a bit in the next set of questions. Cool, so copy them down, and I'll see you on the flip side.